Hey everyone, today I'm going to talk about Frisky. Frisky is a reimplementation of the Dask scheduler and distributed computing system in Rust with a lot of performance features involved. Today I want to give you just sort of a feel of using Frisky. It's a lot like Dask, just smoother, more modern. We're looking at some dashboards, run some computations. It'll be a good time. So I've got an Xarray computation queued up, and I'm going to run it on this cluster of about 20 machines in Amazon. So this is a Dask cluster. Frisky doesn't come with its own deployment solution. We just hijack Dask's solution. So I've got a Dask cluster. It's a normal vanilla Dask cluster. Here's a Dask dashboard. And what we're going to do is we're going to import Frisky and hijack that Dask cluster. That takes a second or two. And then that same dashboard will then work. And that's now running a new dashboard. This is running a new cluster. So I've got Frisky deployed onto all those machines. I can go and see lots of fun things that are going to happen on that cluster in a minute. So let's play with a workload. I'm going to use Xarray with a nice workload provided by the kind folks at Carbon Plan. This is, I don't know, they're trying to save the world. It's a big bunch of data in AWS. We're using Ice Chunk here. Ice Chunk is also sort of a nice modern Rust-based implementation that's useful in the GeoStack. And let's go run a small computation. We're just going to load in a variable, about 100 gigabytes, and compute the average. So I hit submit. Stuff happens. Result finishes in, I don't know, not that long. 5 seconds. So cool. It's easy to do. Let's go and do some other things. And so I want you to notice that when I hit compute in my notebook, the computation sort of immediately arrives on the dashboard. So first thing, graph submission is a lot faster than it used to be. Second thing, the scheduler is also a lot faster than it used to be. Here we're seeing sort of 500 tasks per second, and we're using about 1% of the scheduler occupancy. So Frisky can run at about 100 times more task throughput, so the scheduler's never bottlenecked, 100 times more task throughput than the Dask scheduler. This means larger graphs. This means a lot of insensitivity to small chunks. In general, things are just a lot more smooth. It also means we can operate at much larger scale. I use Frisky at like the 10 terabyte scale in my work pretty comfortably. So we're doing science here too. I don't know exactly what this is, to be honest. Claude built these notebooks for me, but presumably the fine folks at Carbon Plan could tell you all about it. Let's do something else just to see the dashboard charts run. Ooh, looks 5,000 tasks per second, 10,000 tasks per second. Frisky isn't also just about task throughput. We also do things like handle network well. We handle compression well. We handle disk well. There's lots of ways in which Dask was invented at an era when hardware was a lot poorer than it is today. And Frisky just makes different choices based on the sort of much faster hardware that we have today. You can dig into this if you want to. There's a lot of detail about exactly how Frisky works internally, and you can like really dig in on like the microsecond level about what Frisky's doing moment by moment. It's pretty fun. I use these charts when I'm building Frisky. Another thing that's also fun is that Frisky has dashboards not just for humans, but Frisky has dashboards for agents. So here's an example of a previous dashboard that I ran. And Frisky has a CLI that agents can use to get similar views to what humans get on the dashboard, but for agents. And then agents can go and they can go explore this pretty deeply. This honestly is how I use Frisky, how I develop Frisky. I hand Frisky workloads. I then point my agent to the Frisky dashboard, and the agent then tells me what's going on. So it's quite fun, quite sophisticated. I'm not going to get too much into this video, but it is fun. Let's see other things we can play with. Yeah, just a simple, obvious, terrible thing that happens in Dask is like a large rechunk with terrible chunk sizes. Frisky really doesn't care about terrible chunk sizes. Oh, sorry, I need to actually compute that. So it submitted that graph, and again, about sub-second, it ran those computations. They're way too small. They take, 70 microseconds, and they communicate across machines in AWS in a sub-millisecond. But still, Frisky doesn't care that much. There's a lot of white space here, but it was still fairly fast. Let's go and let's submit 1,000,000 tasks to see Frisky handle that. So you can see over here, we're building up 1,000,000 tasks of increment tasks, and Frisky's going to run that. Again, it's not especially a good use of distributed hardware. We are running at about 100 tasks per second, using about half the scheduler. Those 1,000,000 tasks are done. So that's it. So I wanted to show. Hopefully you got to sort of get a feel for how Frisky feels, and you get a sense for how it gets used. If you're an Xarray user, one more thing. I have also re-implemented Dask array in Rust. Not the NumPy part, but the graph generation part. And that's in this new library, Dask_array, which is also available here on GitHub. So it does other things. It does query optimization. It's very smart in lots of fun ways, but you'll also want that. That's it. You should try out Frisky. It's fun. You should replace your Dask scheduler. Almost certainly, Frisky will break. It is very new. I released it literally yesterday. But please try it. Please break it. Please report issues. It's fun. This is not like a business that I've got going on or anything. This is just sort of a fun art project of mine. So I hope you enjoy it. I hope it causes you some progress, or at least it's interesting to you. So thanks. Have a good time.